guys, and welcome back to NASA at Home, where we bring NASA home to you. Today, let's take a look at our commercial crew program, hard at work bringing space travel back to U.S. soil. Let's hear from a couple of our commercial crew astronauts and see what it's all about. Come on.
NASA's commercial crew program is ready for launch. Did you know the last time we launched astronauts from America was in 2011?
NASA is working with companies Boeing and SpaceX to take astronauts to the International Space Station from America once again. Let's look at how this will happen.
Look at the spacecraft on top of the rocket. This is where humans will be sitting. The astronauts will be buckled into a spacecraft, stacked on top of the rocket as it is launched into space. The rocket holds all of the fuel needed to get to space.
It takes a lot of energy to lift the rocket off the ground, with gravity constantly pulling it down, which is why most of the rocket is filled with fuel. During the rocket's climb to space, it will increase in speed, which means its energy will also increase. Once the rocket has made it past Earth's atmosphere, the engine will finally cut off. The rocket and the spacecraft will separate, and the astronauts will make their way toward the station, where they will be working on science experiments and engineering projects.
What do you think will happen when the spacecraft travels back to Earth?
Boeing has made the Starliner CST-100 to keep astronauts safe as they travel to and from the station. It's designed to touch down safely on land in the western United States. The Starliner has parachutes it will use as it prepares for landing, but will also have large airbags expanding under the spacecraft to cushion the landing for the astronauts before stopping completely.
SpaceX's Crew Dragon was also created to send astronauts to and from the space station. As the spacecraft comes back to Earth, the outside will experience temperatures over 3,000 degrees Fahrenheit. The Crew Dragon has been designed to keep the astronauts inside comfortable during the ride home to Earth. Once they are back in the atmosphere, the spacecraft will release 4 main parachutes to slow down the speed and energy of the vehicle before it splashes down in the Atlantic Ocean or Gulf of Mexico. These spacecraft are exciting sneak peeks at the future of space travel.
And NASA's commercial crew program.
Want to know more about space travel? Check out this website for more information.
Thanks, guys. Okay, let's review. NASA has partnered with Boeing and SpaceX, and each has produced a unique spacecraft, a human-rated rocket, and the necessary ground support systems. The spacecraft and rockets will carry up to 4 astronauts and about 220 pounds of cargo for NASA missions to and from the International Space Station, allowing us to resume human spaceflight launches from the United States and open access to low Earth orbit. Now wait a second, what exactly is low Earth orbit? And why is it important to access it? First, let's start with what an orbit is. An orbit is a regular, repeating path that one object takes in space around another one. An object in an orbit is called a satellite. A satellite can be natural, like the Earth or the Moon. A satellite can also be man-made, like the International Space Station. An orbit is a curved path, like a circle or an ellipse. For example, the Moon's orbit is almost circular. But how do objects like the International Space Station stay in orbit? A moving object will continue moving unless something pushes or pulls on it. This is called Newton's first law of motion. Without gravity, a satellite would fly off into space. But thanks to gravity, a satellite is constantly pulled back towards Earth. This tug of war keeps the satellite in orbit. Objects at different heights move at different speeds in orbit. The space station is about 250 miles above Earth in what we call LEO, or low Earth orbit. LEO is the easiest orbit to get into and stay in. At that height, the station must move at about 17,500 miles per hour. It takes the space station about 90 minutes to go around the Earth. So we send our astronauts to the International Space Station. But why is it so important to us? What does it offer us that we can't get here on Earth?
Feeling weighed down? Feeling the constant pull to the Earth? We all are. It's gravity, and it's a part of every single thing we do, including our science. But what if we're 250 miles above Earth, aboard the International Space Station, a laboratory like no other that offers something we can't get on our home planet?
My name is Dr. Serena Anand-Chancellor, NASA astronaut. I recently flew to the International Space Station aboard Expedition 56 and 57. My relationship with microgravity is that I got to live in microgravity for 197 days when I was on orbit. So many people ask, what is microgravity? Why do you float on board the International Space Station? Gravity acts upon all objects. We're never truly in zero gravity on board the space station. But because the space station is traveling so fast around the surface of the Earth, we're actually in a constant free fall. And that's why everything and everybody appears to float on board the space station.
We are experiencing the Earth's gravity. In fact, we're actually experiencing about 90% of what you all experience on the surface of the Earth. The difference is we're just moving so fast that as we fall, we actually fall around the Earth, and that defines orbit. So microgravity means we're not, it's not the absence of mass, which of course creates gravity, but all the objects together are in the same gravitational field and all falling together. So yes, it is a lot of fun. Floating around, of course, is one of the exciting parts of being up here on board and being an astronaut, but even more importantly, it lends itself to all the amazing experiments that we can do on board that take advantage of that microgravity environment to do things that we can't do on Earth, but that can benefit life back on Earth.
The important thing is it's so different than what we have here on the ground, where everything is pulled by the Earth at what we call one force of gravity. And what that does is it allows you to see the small forces, the small processes, the small effects of what goes on in life cell development or technical processes like combustion or fluid flow. And it helps you understand things that you may not have fully understood on Earth, where you see something happening, something assembling or disassembling, or the shape of something now going into 3 dimensions. And you learn, that's really what was driving this thing on Earth that we didn't really understand.
On Earth, gravity is affecting all research we do, and sometimes that can get in the way. Studying things in different environments can give a better picture of how they work, from diseases to fires and even things that make up products like milk or shampoo.
One of the main things we perform on the ISS is science. In fact, probably 70 to 80% of our day is performing scientific experiments.
It takes a lot of people to make all of that microgravity science happen. 4,000 scientists, companies, and students from over 100 countries have sent more than 2,700 experiments to the orbiting laboratory. Over the past 20 years, these studies have unlocked new discoveries and even kicked off hundreds of new microgravity experiments.
So it turns out the International Space Station is a really important research tool, benefiting all of us here on Earth. Let's meet one of our engineers who built an experiment for the International Space Station.
I'm Monica Duzick. I'm from Avon, Ohio, just outside of Cleveland. I graduated from Rose-Hulman with a degree in chemical engineering, and I now work as a gas and fluid systems engineer at the NASA Glenn Research Center, where I design and develop new technologies for everything from cryogenics to fuel cells to experiments on the International Space Station. I love engineering because it lets me solve new and challenging problems every day. And my advice to students, always work hard, follow your passion, and never, ever give up.
Once we built and tested all of the different parts of the spacecraft, we still need to flight test it as a whole before we add the final component, human astronauts. Let's take a look.
So we're going to have an orbital flight test, a test without the crew in it of each vehicle, and then we're going to have the first flight with crew in them to prove that these systems are ready to fly people to space.
These demonstration missions are important for astronaut safety because, the folks around here that I work with, we all ask ourselves, would we be comfortable flying our own family on board this vehicle? And the answer has to be yes. And so because of that, we need to make sure we test these as much as we can.
since we're dealing sort of with a new generation of people who are putting human space vehicles together again, I think it's important to impress upon them every day that there is not a day where their attention can waver.
We can test them down here on Earth. We can put them in vacuum chambers and acoustic chambers and, do thermal tests on them. But there's nothing like going up and putting them in the real environment.
That will give us a lot of insight on the vehicle performance, the functional systems, even the abort system will be active on that vehicle.
So that's why these initial test flights are so important, is because you need to see it's not just the hardware, it's also the software, it's the people, it's the procedures, it's the whole thing coming together.
Boeing's supposed to land on land, SpaceX is supposed to land in water. Those are two hugely different environments, so there's a little bit of interest in the survival equipment that's located in the spacecraft as well, where that's going to be, how that's going to work.
This is a really critical aspect of the NASA job, is to continue to have that dialogue with the contractors about, well, why did you do that? Why was that safer?
This is someone's family member, husband, wife, uncle, aunt. It's not an option to not be successful. We have to be successful.
10, 9, 8, 7, 6.
On March 2nd, 2019, at 2:49 a.m. Eastern Time, SpaceX's Falcon 9 rocket with the Crew Dragon spacecraft on board launched from Kennedy Space Center's Launch Complex 39A in Florida. Called the Demo 1 mission, it was the first uncrewed test of the Crew Dragon spacecraft and was the first launch of an American spacecraft and space system built and operated by our commercial partners and designed for humans. The launch, docking at the International Space Station, and landing in the ocean were a complete success. The Crew Dragon was the first space vehicle to dock autonomously, or on its own, at the International Space Station.
Did you know that SpaceX's Falcon 9 rocket that launches their Crew Dragon capsule to the International Space Station is able to be reused for flight? This means that after separation, the first stage re-lands on Earth for use in the future. Thanks to the Falcon 9, SpaceX was also the first commercial company to ever visit the International Space Station and has made many trips to deliver cargo for NASA, as well as to deliver satellites into orbit. The ULA Atlas V rocket that launches Boeing's Starliner capsule to the International Space Station is another tried and true rocket, having been launched over 80 times. Atlas V's have carried payloads like the Juno space probe, the Mars Curiosity rover, and more into orbit since 2002.
4, 3, 2, 1, and liftoff. The rise of Starliner and a new era in human spaceflight.
The Boeing flight test launched successfully on December 20th, 2019 at 6:36 a.m. Eastern Time. Although many of the flight test objectives were met, the spacecraft was unable to rendezvous with the International Space Station. The spacecraft did land safely and successfully 2 days later at White Sands Space Harbor in New Mexico. While the launch and landing were successful, Boeing plans to redo the flight test to show that they meet all of the test objectives before launching the CST-100 Starliner with astronauts aboard. As always, when it comes to NASA, safety is our #1 priority. Here's something you can build and test at home, just like a NASA scientist or engineer. I challenge you to plan, build, and test a parachute that will slow an egg as it falls so that it lands gently and doesn't break. We'll pretend that the egg is a person and dub him our little eggstronaut. This is my eggstronaut. His name is Bob. Now, we want to make sure Bob is protected. He'll need a good parachute that slows him down and something for him to sit in so that he doesn't break when he lands. Bob! All right, to begin your mission, you'll need some materials. And these are all things that you can find around your house. So feel free to raid the recycle bin, look in your crafts, Ask mom if she has any old wrapping paper, tissue paper, ribbon, things like that she wouldn't mind you using. Just make sure you have permission to use whatever you decide to use for your parachute. So the first part you'll need is the actual parachute, right? So you want something that's going to catch a lot of air as it tries to slow that egg. And also you want it to be lightweight, because if it's real heavy, it won't have time to open up and catch that air to slow it down. So things like coffee filters, tissue paper, plastic bags, all of these things work great. Anything you can think of, the sky's the limit. Now next you're going to want a capsule, because of course our little eggstronaut needs somewhere to sit. So you can use a cup, you can cut up a bottle, you can use a little box if you have one, you can build something for the little eggstronaut that looks maybe more like a NASA capsule, whatever you like. And then you're going to need a way to attach the two together. So maybe some string or some ribbon, rubber bands work. You can cut them and attach them. It depends on how big you want it. If you want something a little more solid that doesn't bend so much or move so much, you could also consider using straws. Use your imagination. Whatever you can think of, that's what you should try. Now you will need, to put it all together, you will need potentially some scissors, you will need some tape or some glue, and you'll also, to make your life easier, if you happen to have a hole punch, sometimes that makes it easier to tie things together. Put a little hole punch in there and tie it up, but you don't have to have one. Now you will need a measuring tape or a meter stick and a drop zone. So what does that mean? Well, once you put your parachute together, once you've gone through the entire process and you're ready to drop your parachute with your little egg, you're gonna need a place to drop him. Now, make sure this is a place that is safe for you to stand, has enough height for you to drop him, and that no one will be going underneath of you. So it's always a good idea to have maybe mom or dad drop the parachute and you stand below, keeping an eye out, make sure nobody walks through the drop zone. But you're gonna wanna use that measuring tape and measure about 2 meters or more in order to drop your parachutes. And last but not least, you're going to need your egg. Now make sure your little eggstronaut is a hard-boiled egg, and you can have an adult help you with that. We don't want to be dropping raw eggs, especially inside the house, but also around the house. It'll leave quite a mess, and mom probably won't be too happy with you. So make sure you hard-boil your egg with the help of an adult, and also you can use a plastic egg if you prefer. You can even fill it up with, stones or a little dirt to make it a little heavier. Just make sure you tape it closed so that it doesn't pop open on you and spill everything everywhere. The weight of the average egg is about 57 grams. So if you are a serious scientist and you just happen to have a kitchen scale, you can fill that plastic egg up so that it weighs about the same as your average egg. All right, so those are all the materials that we need. It is time to get started. For more detailed instructions and educator resources for this challenge, check us out online. When an engineer wants to solve a problem, they use what we call the engineering design process. Sounds fancy, but you've probably used it yourself without even realizing it. People who do all sorts of jobs, not just engineers, use this process every day to solve all sorts of problems.
Step 1. Ask.
What problem are you trying to solve today? What are you trying to create?
Step 2. Imagine.
What do you think a great parachute would look like? Think about how it's shaped and where you'll put the egg.
Step 3. Plan.
A good engineer always makes a plan before building something, usually drawing a sketch or making a small model before building the real thing. Plan how you will make your parachute by drawing a picture of it or telling a family member or friends how you plan to build it.
Step 4, create.
Now go and build it. Use your plan from step 3 to build your parachute.
Step 5, test it.
With your parents' permission, test your parachute design with the eggstronaut. Drop it the exact same way from the exact same height at least 3 times. And if you have a stopwatch or a phone available, you can time it and record your data. Now, did it work the way you wanted it to? If it didn't, that's okay. Part of building something new means learning from your mistakes. Here at NASA, we know that failure in the beginning of a project means a much higher rate of success at the end.
Step 6, improve.
Once you've tried your parachute out, maybe it didn't work quite the way you wanted, or maybe you see ways you can improve it. Keep improving your parachute until you've got it just the way you want it. Engineers test their designs over and over to improve them each time. And some designs get thrown out completely.
And step 7, share it.
Sharing your design with friends, teachers, and parents will give you more ideas that will make your parachute even better. Here at NASA, we test everything over and over to be sure it is safe and effective. Now let's meet one of our instrument maker apprentices who helps build sensors used in testing here at NASA.
Hi, I'm Rafael Mercado and I'm from Cleveland, Ohio. When I was younger, I loved taking things apart just to see how they worked. That led me to earning my associate's degree in manufacturing and industrial engineering technology. I currently work at NASA Glenn Research Center as an instrument maker apprentice. I make and install sensors on models. This helps engineers and researchers visualize what's happening to the hardware during a test. My advice to students, don't allow anyone or anything to prevent you from achieving your goals. Hard work and dedication can open almost any door.
Now, occasionally we have to scrub a launch. No, that doesn't mean that we have to clean it. It means that we're not going to launch that day. We've decided we're going to try again on a different day. But why do rockets scrub? Well, launching a rocket isn't easy. Years of work go into each mission leading up to launch day. And launch control operations always err on the side of caution, especially when they're launching a crew. Now, there are several reasons to hold up a launch. First of all, of course, weather. Severe thunderstorms, strong upper winds, or cold temperatures could delay a launch. Also, technical concerns. If any of our systems, such as our rocket or spacecraft, any of the payload or ground systems, if we have sensors detect that something isn't right, we need to check it out. And airplanes and boats, if they fly or drive into our safety range for the rocket, that can actually be a problem. And lastly, nature. Now, what do I mean by nature? Well, actually, there's a funny story that goes along with that, and I'll let astronaut Don Thomas tell us all about it.
Hi, I'm Don Thomas, one of the Space Shuttle astronauts, and out of the 135 missions of the Space Shuttle program, I have to tell you the most unusual and maybe the most exciting moment. And one of the trainers said to me, "Hey Don, they're talking about delaying your mission because a woodpecker attacked the space shuttle." And what happened? Some lovesick woodpecker, a single northern flicker woodpecker, made an attack on the space shuttle. It started poking holes in the foam insulation of the external tank. And the foam on the tank is 2-3 inches thick. So this one single woodpecker ended up making 205 holes in the foam of the insulation of the external tank there. NASA tried to patch up the holes right on the launch pad. They tried and tried, but after about a week, they finally said, we can't patch these safely here. And they made the decision to roll Space Shuttle Discovery back to the VAB. And they were there for about a week or so, maybe 10 days, and patched up all the holes, all 205 of them. And then they rolled it back out to the launch pad for a second launch attempt. And everything was fine, except NASA still had this huge problem. Well, what do you do with the woodpeckers? How do we prevent any woodpeckers from coming back and doing this again? And people from around the world sent in their ideas about woodpeckers and how to keep them away. One of the ideas was to put plastic owls all over. So all over the rotating service structure around the shuttle, they had these 2-foot-high plastic owls there. An owl is a predator, the natural enemy of a woodpecker. So the idea was that a woodpecker would see an owl and not come anywhere near the shuttle. NASA also put out these big beach ball sized balloons. They were called predator eyes. And it was the size of a beach ball, and they would have these large eyes on them, very similar to the eyes of an owl or eyes of a hawk. And again, the idea was that a woodpecker would see those eyes and think, oh, that's a huge predator there. I'm not going anywhere near this shuttle. They had screeching owl noise and hawk sounds that they would blast around the launch pad. I'm not sure it kept the woodpeckers away, but for a fact, it annoyed all the workers out there preparing Discovery for launch. Everybody complained, evidently, that all that screeching noise was driving them crazy out there. But in the end, there were no more woodpecker attacks. It was the one and only instance in the history of the Space Shuttle program that we ever rolled back the shuttle for a reason other than the weather or some technical problem. And it was just the woodpecker attacking the shuttle.
We interrupt your scheduled programming for this NASA News Update. Hi, I'm Rod Chappelle for NASA at Home. NASA's commercial crew continues to advance space travel for the United States. On May 30th, 2020, history was made as NASA and its partners brought space travel back to the United States, launching American astronauts from American soil for the first time since 2011. NASA astronauts Robert Behnken and Douglas Hurley launched atop a SpaceX Falcon 9 rocket from Kennedy Space Center's Launch Complex 39 before flying to the International Space Station aboard SpaceX's Crew Dragon spacecraft.
So rises a new era of American spaceflight.
The excitement was palpable as Americans all over the country celebrated this historical event.
Dragon is now officially making its way to the International Space Station today.
The flight test, known as Demo 2 mission, provides critical data on the performance of SpaceX's rocket and spacecraft, as well as all launch and landing operations. This is the last major step before NASA can fully certify the system for routine crewed flights to the orbiting laboratory, marking the major step in the commercial crew programming.
What an exciting time to witness history in the making. Thanks for joining me today for NASA at Home as we continue to launch America with our commercial crew program.